Guys, welcome to Java Core Programming course, section 1 and lecture 5. We continue discussing and studying Java basics. This lecture's agenda. Today's agenda is increment and decrement operators, postfix and prefix form, arithmetic operations on short byte data types, integer arithmetic errors. Let's begin today's course. Increment and decrement operators. Increment and decrement operators are unary operators that operate on a single operand. Plus plus is the increment operator, minus minus is the decrement operator. This operator adds 1 to the operand. Decrement operator adds one, subtracts 1 from the operand. Increment operator increases 1. Decrement operator decreases 1. These two operators have higher precedence than the arithmetic operators. Please keep in mind, precedence is important. Whenever there is a unary operator and a binary operator, the unary will be operated first. These operators only work on integer operands. Okay, next, pre and post operators. Both decrement and increment operators have two forms, prefix and postfix. They have their own implications. For example, prefix increment operator. For example, it increases first then assign. For example, int y is equal to 10 and x is equal to plus plus y. So here it will increase y and then assign it to x. So result will be y is equal to 11 and x is equal to 11. In postfix form, it assigns first and then increase. So in the same example, int y is equal to 10 and int x is equal to y plus plus. In this case, this will assign value of 10 to x and then increase y. So the result will be y11 and x is equal to 10. So same happens with the decrement. Decrement operator in the prefix form decrease 1 first then assign. In postfix form decrease later and first assign. So int y is equal to 10 and x is equal to minus minus y, both becomes 9. In case of postfix form, y is equal to 10 and x is equal to y minus minus. The y will be decreased after assigning y to the x. So it will become 10 and y will become 9. Okay, both arithmetic operations on shorter integer types. So this is very carefully, please consider these operations carefully, because whenever we use bytes and short data types and we do arithmetic operations on them, they always converted to integers. And if we try to assign them back to byte and short, there will be a need for explicit casting. If we don't do that, there will be an error. So as we studied, byte and short can store only smaller integer values. But for arithmetic operators, the default integer operation requires integers or long operands. They must be long or int to store the values. When we operate arithmetic operations on byte or short data type variables, they are implicitly converted to int or long variables based on the operands involved, or reference to store the result. So for example, if we have byte b is equal to 5 and we have byte c is equal to 5. And if we do the operation byte result is equal to b plus c, this will be a compiler error and syntax error, because b plus c, the plus operator convert them into integers, and the result will be an integer that cannot be stored on the byte no matter it falls within the valid range of byte, but we have to convert them. If we like to store the result into a byte variable, we have to cast it explicitly using the cast operator. That will be that I will discuss in the lecture 6. Arithmetic errors. How the arithmetic errors happen. For example, division by 0 is an exceptional case of math error because division by 0 is not defined in mathematics. Any number divided by 0 is undefined in math. In programming, it raises an exception and crashes the program. We will read more about exceptions when we handle them in future lectures. Overflow error. There is an other error, overflow. Overflow error is while doing the arithmetic operations on integer data types, the result is a larger value than the maximum limit of integer data type. In previous lecture, we have seen that every integer data type has a maximum limit. For example, byte has 127 maximum number to store and the minimum number is minus 128. Similarly, short, int and long, they have minimum and maximum value. What happens if an operation ends up a larger or the smallest value than their maximum number or minimum number? So this is when an overflow occurs. An overflow normally results in a negative value. For example, if there is a very huge positive number as a result of an arithmetic operation and we try to store it on integer or long, and the result will be a negative value because of the overflow, and that will be a logical error. Underflow error. Underflow is similar to the overflow error. Underflow happens when we get a smallest value that the data type cannot store. It results in an invalid value. So these are arithmetic errors that may happen in the arithmetic operations. All integer data types have fixed lowest and highest values represented by min value and max value constants in their wrapper classes. We will discuss the wrapper classes in future section when we discuss the string class. Along with string class, I will discuss the wrapper classes of the intrinsic or internal data types provided by the Java programming language. Thank you guys. That is all about today's lecture. Let's go to practice these concepts that we have studied today. Hello guys. Let's begin the practice for the lecture 5. Create new class. Name it lecture 5. Add main method. Okay, let's declare some variables. Int, let's say x is equal to 10. Int y. So we initialize it to 0. Okay, let's print them. Printf %d x is equal to and y is equal to a new line x y. Okay, now increment operator. In case of increment operator, we have two forms. Let's try first one. Y is equal to x plus plus. This is postfix form. Assign first, then increase. Let's see what happens to the values. Okay, Let's run it. Okay, see here. X is equal to 10. It is assigned first, then it is increased to 11 because of postfix form. Now let's retain our values back, 10 and y is equal to 0. Okay, prefix form. In prefix form, y is equal to plus plus x. In this case, both of them will have same value because it increase the value of x and then assign it. So let's print and check. See, we have x is equal to 11 and we have y is equal to 11. Same goes for the decrement operator. Okay, same values, and we do postfix decrement x minus minus. Then we will reassign them. Let's print it here, postfix, and this is prefix. In case of prefix, values will be different because it decrease first and then assign the value. Run. Okay, here decrement operator, we have x10 y0, so we used postfix form. It assigned the value first, then decreased x, so y is 10 and x is 9. Here we have used prefix form. In case of prefix form, it decreased the value of x to 9 and then assign it, so both values will be same. Okay, now next, our next topic is shorter data types. Okay, let's see. Shorter data type, let's say integer and arithmetic operations. Okay, so let's we have byte b is equal to 5 and byte c is equal to, let's say, 10. Okay, that is good so far because these numeric values are literals fall within the range of byte. Now another variable. So if we add 10 plus 5, it becomes 15. So if we declare byte a is equal to 15, that is absolutely fine. There is nothing wrong. Now if we operate, let's say plus, so byte result is equal to b plus c. Here error, because when we used plus operator, these two byte values converted into an integer, and the result of this operation is an integer. We cannot directly assign an integer value to a byte. We have to convert it by using cast operation. In lecture 6, I will discuss the usage of cast operation. So it has to be integer or it has to be cast to byte. See, now it is int and it is all right. So let's print result. It should print 15. Okay, it has printed 15. Same goes for the short value. Let's say short, we have s is equal to 9, and s is equal to s plus, let's say a, let's say b. Okay, b is 5. So result should be 14, but it is an error because of arithmetic operation. Same goes for division, multiplication, and subtraction operators and modulus operators. All these 5 arithmetic operators convert the shorter data types into an int or long based on the operand types. So we have to use result here because the result is an integer variable. Okay, let's print it again. We have 14 here and we have 14 here. Now in case of, let's say we are combining two different results. Let's say int I is equal to 3 and result is equal to 3 plus a. No error because this is a is byte. Okay, byte will be promoted to integer. Integer plus integer, result is integer, and we are perfectly fine with the result. Okay, that is the result of addition of C and A. Okay, now arithmetic errors. In case of arithmetic errors, the overflow and underflow occurs. Okay, let's try this. System.out.println. Okay, integer dot max value plus integer dot max value. These are two largest integer values. Let's see what happens. Okay, see the result is -2. This happens because of this is the largest number, the maximum number an integer can hold. So the result will be, let's store it to some variable. Let's say result is equal to this. Okay, and print this value. -2. This is how overflow happens. Overflow happens when the largest value that is bigger than the maximum number or data type can hold, and the larger number is truncated, and the result is converted to negative because of binary representation, because all these integer numbers are stored in the memory as a binary numbers. Okay, now underflow. Okay, let's add the minimum values. Min value. Okay, and this is also min value. Let's see what happens to the result now. Run it and see, it is 0. These are the minimum values and the result is 0. And if we don't use and print the minimum value, and this is how smallest value is represented. This is the smallest value that an integer can hold, represented as -2 power 31. This is the value, and if we add them, min value, the result is 0 because the value is truncated. It is a junk value, basically a logically incorrect value. So what happens in case of math error? Math error occurs when we divide by 0. Let's say int x is equal to 9 and int, let's say y is equal to 0. I think we have these numbers already. Let's set the values. Okay, divide system print x divided by y. This is division by zero exception, mathematical error. See, arithmetic exception, because division by zero is not allowed, and it is not even defined within mathematics. So whenever we do division, we must consider the denominator should not be a zero. So these are the arithmetic errors and post and prefix of increment and decrement operators and arithmetic operations on shorter data types, and what happens. We have practiced all the concepts, and I hope you have learned it. Good. Thank you guys. Have a good day and see you in the next video.